Let's take some time to fully understand this module interface document. Keep in mind, a document like this is included with almost all the modules you will find on AMX.com. As you can see, one of the first items you encounter in the document is a nice color picture of the device you intend to control. In our case, there's a picture of the Lexicon RT20. This is handy because it's a great visual reference to make sure you have selected the correct module for your player. Next, you'll see a table of contents for quick reference to specific information you may be looking for. Here, the revision history is a chronological list which tells you what features have been added to the module with update history. The next table we see is the wire pinout diagram, which also includes the connector type used to connect the third-party device. As you see here, our RT20 uses a DP9 for serial control. The zip file you downloaded to get this interface document actually contains a complete working project with all needed files, including a master source code file called main, the UI code module, the Java COM module, and even a working touch panel file. The diagram you see here actually explains how all Duet modules work. Therefore, please review the following description of the flowchart diagram as many times as needed to gain a good understanding of how Duet modules work. As mentioned above, you could simply set all the device numbers in your hardware to match what appears in the main AXS file. Then load the entire workspace to your master controller and touch panel, and you would be controlling your third-party device. So this diagram explains how the pre-built module works. The only item not shown in the flowchart is the main.axs file. That's because it's only used to call the other files and define the devices. Starting on the left, we have the UI code file. Typically, this would be code you write yourself, which defines the channel number associated with each button. In a real-world scenario, you could include all the code shown here in the main and the UI into your already existing master source code file and just call the Duet module using the define module keyword. The next item in the diagram is the virtual device. The virtual device is how Netlink's code interfaces with the Java code in the module. Therefore, after you have defined the virtual device to talk to the module, all interaction to the third-party device goes through the virtual device. Now, the module uses the Snappy to pass data back and forth between your code and the module. This is sometimes referred to as the Snappy router. Next, we have the COM module. This is compiled Java code which acts as an interpreter between Snappy commands sent to the virtual device and the actual strings sent to the third-party device. The following diagram illustrates what this interpreter is doing under the hood. Lastly, in the flowchart, we come to the third-party device we are communicating with. So the last bidirectional arrow just indicates that communication flows between the COM module and the real device using the third party's protocol. If you scroll down to the next section called Channels, you'll see all of the available Snappy channel functions available for the Lexicon DVD player. Let's scroll down a little to see the channel code 27. Just like with all Snappy devices, channel 27 is reserved for power on. The efficiency you gain by using the module is that you as a programmer don't have to know anything about the third-party protocol. In this example, if we wanted to turn on the Lexicon DVD, it's as simple as pulse VDV DVD, 27. Now when the module receives the pulse on channel 27, the COM module will know to send the appropriate serial string to the player and power it on. Scrolling down further, we see the command control list. This section is pretty self-explanatory. The left column contains the command to send, and the right column explains how the command is used and defines the available parameter list for each command. Two important features in this list warrant a more thorough explanation. Those are pass back and pass through. To view return data beyond the scope of the module, you may wish to see the uninterrupted data coming back from the third-party device. To do this, simply turn on the Pass Back feature. Another useful feature of the Duet modules is the ability to take advantage of more advanced features which may be supported by the third-party device, but are not natively supported by the module. In order to take advantage of the pass-through feature, you will need to know and understand the language of the device, which may include some combination of bytecode in ASCII, hex, or decimal format, as well as checksum calculations. For more information on implementing the pass-through feature, see the Adding Functions to Modules section in the bottom of the interface document. Next, we move on to the Command Feedback section. This section simply informs the programmer about the format in which the commands from the virtual device are returned. It is worth noting here that all data returned to the programmer comes back as a command event from the virtual device. The Programming Notes section just offers more detailed information about the default functionality of the module. And we have already covered how the Adding Functions to Modules sections is used. So there you have it. That's an in-depth look at the Duet module interface document. Now that we fully understand this document, let's get back to implementing our first module.